All right, here's an example where we want to find the zeros of the function. So we're going to start by factoring it. So we're going to set the function equal to 0. And then we identify the a, b, and c. So the a is 1, the b is -8, and the c is 0. So when we set up our diamond, what are the factors of AC? So 0, that adds to -8. Notice that this doesn't work to do the diamond. And the reason why is this has a GCF. So we take out the greatest common factor, which is x, and we're left with x minus 8. So now we use our zero product property. X quantity x minus 8 equals 0. So the first factor is the x, and we set that equal to 0, so x equals 0, and that's done. Set the second factor equal to 0, x minus 8. And then we solve it for x, so we add 8 to both sides. So we get x equals 8. So our two solutions are x equals 0 and 8. These will be the x-intercepts when we graph the function. All right, here's an example. We have another quadratic equation. It's not in standard form. So we're going to move that 25 to the left. So you're setting it equal to 0. We can factor this one by the difference of two squares. Remember that rule is if you have a perfect square minus another perfect square in factored form, it'll be a plus b, quantity a minus b. So I'm going to rewrite the expression as two perfect squares. So we get 2x times 2x is 4x squared, and then 5 times 5 is 25. So in factored form using our rule, it'll be 2x plus 5, quantity 2x minus 5. Now I'm going to go over to the second box and set up our zero product property. So we have 2x plus 5, 2x minus 5 equals 0. So here's our first factor, set it equal to 0. And we solve it. So we subtract 5 from both sides. And we get 2x equals -5. Then divide both sides by 2, and we get -5 halves. We set the second factor equal to 0 using our zero product property. 2x minus 5 equals 0. We add 5 to both sides. 2x equals 5. Then divide both sides by 2. So our two solutions are -5 halves and +5 halves.